Hello, everybody. Welcome to the last week of February. It's exciting. We are getting ready in here to start Unit 6. And so now that we're starting Unit 6, that means that we are in geometry for the rest of the year. We're going to learn some big milestone things about geometry, stuff that's important for you guys in your learning in algebra even, but that you're going to need to dip into when you guys get to geometry as a sophomore. So some stuff that you definitely have not seen before. This will be new. And the goal is going to be to kind of finish up, try to get through 2 units before our state test. Our state testing is the last week of April. And yeah, we're going to try to get through that and then just have 1 unit left over. And just kind of try to review. That's going to be pretty hard virtually reviewing. I'll have to figure that out. But that's the goal. So we'll work towards that. Today we're going to start transformations. Transformations are ways to move things on a graph. And I say ways to move things because I didn't want to be specific there. We can move lines, we can move shapes, we can move angles, we can move segments. All things that you guys think when you hear geometry, you just think, hey, we're talking about shapes probably, right? It's not necessarily the case, right? Geometry is all sorts of things. Lines and even when we've been doing linear algebra, there's a lot of geometry in that when we graph and things. So there's 4 types of transformations. We're just going to talk about translations today. All right. A translation sounds like you're going from Spanish to English or something. Is a slide or a shift. And literally what's going to happen is we have this shape and we just slide it or shift it to a new location. And when you translate something, it'll usually give you directions like translate the triangle, and then it will tell you like an ordered pair, like 6, -4. Well, that thing next to it is not actually an ordered pair. That's going to tell you how much to move. So this first number is kind of like an ordered pair. That's kind of like an x value because it's going to tell you left or right. If it's positive, it's going to go right. If it's negative, it's going to go left. The second number in this ordered pair is kind of like your y value because it tells you up or down. And again, positive is going to go up, negative is going to go down. So whatever shape we're talking about here, or whatever line segment or whatever anything, if it said translate 6, -4, that's going to mean we want it to go to the right 6 units and then down 4 units. So we're just going to take this triangle, move it right 6, down 4, and that's the new home of the triangle. So a couple just housekeeping things. Let's use a triangle. I want to show you guys what we would do here with a triangle. All right, so let's say we have a triangle and we have some vertices. All right, that's the points where the triangle is. Right here and right here and right here. And typically shapes are going to be named with letters, if you didn't know that. So let's say we call this A, B, C. It's a pretty typical triangle. The vertexes will always be labeled with capital letters, which is, why maybe a math teacher prior to you or prior to me has yelled at you for using a capital letter for something. Typically, they're used for angles, angle measures, and things like that. So triangle, we just call this triangle ABC. Usually we go in alphabetical order. You don't have to. Sometimes people get creative and called like triangle CAT, you know, super cute, right? So let's say we wanted to translate this triangle, and let's go, what do we say, 4, -6? Let's do that one. So, what this is going to look like, I'm going to use a different color. Maybe orange. I'm not sure if orange will show up for you guys, but we'll try it. So when I translate, every single point, A, B, and C, are all going to move what this says. And that's going to be to the right 4 and down 6. So over here, A, we're going to go 1, 2, 3, 4. And then down 1, 2, 3, 4, 5, 6. That's going to be right there. Over here at B, we're going to go right 4. And down 1, 2, 3, 4, 5, 6. This isn't going to look great, is it? And then, what do we got? C. 1, 2, 3, 4, 5, 6. Throw some extra lines on there. It's going to move over to here. Cool. Now, when we put this triangle back together, mine don't look super. That's just because I hand drew my graph, which is not a really great example. But there's a couple things that we can talk about. First of all, the angles are still going to be kind of labeled the same way. There's two kind of ways that they can do this. My favorite way is to put a prime next to the letter. So that's going to be A prime, B prime, and C prime. It kind of looks like just an apostrophe. And basically it means that this is the new A. So A was there, and now the new A is over here. When we move it to the right 4 and down 6. The other way that they can label these is use the same, like different letters. So for example, if this was A, B, C, they might call this one D, E, F. But the important part to realize there is that the letters will still correspond the same way. So if A was the first in the alphabet here, then it goes to D because that's the first one in the alphabet down here. I will try... I like using the primes, but I saw one time on a state test that they used like different letters, so I want to make sure that you guys know that in case that happens to you guys. I don't want you to miss problems because of that. Now, something else that's interesting here that you need to know about, and that is that these two shapes, even though mine don't look very good, are supposed to be congruent. And if you guys don't know what congruent means, it's like the geometry's way to say equal. All right, so basically, these two triangles are the same shape and the same size. All parts are the same. All right, so in geometry, we typically don't say equals, like a side of a triangle doesn't equal another side of a triangle. Maybe angle measures, we might say that. Like an angle measure, angle BAC could equal something. But usually we're going to use congruent if they are equal to something else. So we would say maybe the angle A is congruent to angle A prime, which is true. Since these two triangles are exactly the same, even though, again, mine don't look great, something that you should learn about in geometry, Don't ever think about things because they look a certain way. Don't, on your test, don't ever write because it looks that way, or it looks like they're equal, or it looks like it's 90 degrees. That's never good enough for geometry. You always have to prove everything that you can say. So I know that every time that I translate, if I just slide something or shift something, my two shapes have to be the same, because there's not enough stuff there that's going to change it. All it's going to change is the location of the shape, or the line, or the segment, or the ray, whatever. So a slide or a shift, they're always going to end up being congruent. So if things get translated, always congruent. That's very important. All right, so we're slided. We talked about what that looks like. We showed you guys that. There is another way. So typically, they might say, hey, draw this shape, but usually what they want you to do is write down where these ordered pairs are. So over here, A prime is at 1, -5. Whoops. 1, -5. B prime is at 1, 2, 3, 4. 4, -1. And C prime is at 3, really far down. 1, 2, 3, 6, 7, 8, 9. 3, -9. And that would be my answer, or what you guys would want to write on your homework, the new points. So A prime is 1, -5. B prime is 4, -1. C prime is 3, -9. What's cool is, let's say you don't want to graph that. There's another way you can actually get those numbers. And I want to show you guys that, because I think it's actually really helpful, especially if you don't really love graphing that much. Let's say I told you that we had a quadrilateral with vertices of -4, 9, -2, -3, 5, 8, and 7, -11. All right, so we have some quadrilateral. That's where its points are. We can even call it A, B, C, D if you want. Boom. So let's say I wanted to translate this shape, and let's say we wanted to go -2, 7. So I want to go left 2 and up 7 on every single point. I wanted to move left 2, up 7. Well, what's cool is we can just take this -2, 7 and add it to each of these vertices. So literally what I'm going to do is set this up. We're going to add -2, 7, add -2, 7, add -2, 7. And when you add, you're just going to go like the x's together. So -4 plus -2 is -6. 9 plus 7 is 16. So A prime would be at -6, 16. And we just do that for every one. -2 plus -2 is -4. -3 plus 7 is 4. That's B prime. 5 plus -2 is 3. 8 plus 7 is 15. That's C prime. And then over here, D, 7 plus -2 is 5. -11 plus 7 is -4. And that is D prime. So without graphing this thing and counting, I can actually still figure out where it's going to translate to. I just take whatever that translation factor thing is, and I add it to each point. And that's going to give me my new points. Yeah. All right. That should give you enough info at least to do tonight's homework and try it out and see how you do. This is all going to be real new. So if you guys need help, I know I say this every single time, but make sure you come to office hours. Make sure you guys are asking questions, and I can help you guys out. We only have 3 more tests for the whole year. Count them, 3. So not a lot of change in your grade there. But yeah, we're moving right along. All right, cool. Hopefully you did great, and I'll see you later.